Welcome to another lecture of Seismic Data Processing course. So in today's lecture we start talking about the waves. The wave is a pattern in which energy like sound, light can travel through space or through matter. So also the scientific definition is a disturbance or oscillations that move through the medium like air, water or rock, or through empty space in case of light. We have four types of waves: sound wave. The medium is the air. When we start talking, we send a vibration in air pressure. Okay, we have radio wave. This radio wave no need any matter to travel. It can travel through vacuum. And for example, for light, that's why the light is reached to the earth very fast, because it didn't need any matter to travel. It just travel through the vacuum space. And for example, for radio waves is considered as vibration in electromagnetic field intensity. And also you have the water wave, propagation of the water waves on the surface of the water, vibration and water surface height. This is the what varies. The one we are focusing on in all this course about the seismic wave is vibration and elastic deformation of rock. What is the elastic deformation of rock? So when we send the propagation of seismic wave and go to the earth, this wave is called elastic deformation. That means it change the density and porosity of each rock. So each rocks have different properties, different density, velocity, composition. So when we generate the seismic wave, the rock will be integral to elastic deformation. It is just temporary deformation in micrometers or nanometers, and then will back to the original shape after this wave is removed. Also, the media that the seismic wave trouble, of course, is the earth rock layers. So evolution of seismic recording. In the past, they were recording mechanically. There is a needle draw sequel lines, this is wavefront, on a moving paper. So there is a moving paper and to draw the seismic wave. And then next generation they use magnetic tapes to record the seismic wave. And then with the developer of the digital area, for the developer of computers, now everything is recording digitally. So understanding how this wave, continuous seismic wave, is how to convert it from analog seismic wave into digital is very important in seismic data processing. So in theory we generate the seismic wave and we have the horizontal layers. We hit the horizontal layers and then the wave is back, and then we record how much time it takes for this wave to back from one hit layer into the geophones. But in reality it's totally different. We have a lot of obstructions. The most important, we have the receiving array. If you're receiving array, your geophones, or in case of the marine, the hydrophones, if the spacing is very low, that means we will miss a lot of reflecting seismic signals, and this is the most important, is the reflection. So for example, we have in here the surface chaos. So when the seismic wave is reflected, this surface chaos is some of the surface wave will interfere with the reflected seismic signal, and these cause some of the energy to lose. And also in the case if we have steep dips, for example fault, so most of the time we have faults within our geological subsurface layers, and this fault, when the seismic wave hit the fault, so it will be bounced back not directly to the receiving array. It will bounce back in different direction. And also if you have a thin bed, it will be very hard to catch this is the changing, the smalling in these layers, because it's the thin bed is hidden with the very thickness bed. So also it's not easy to catch the thin bed. So the receiving array is very important. It play a major role to capture all these thin beds, that mean very high resolution. Okay, input and output for processing. This is the raw data, and this we trying to shift the data from time, we convert it in the depth. so we have the better understanding of geological subsurface layers. And this is what we are focusing in this course, how we input the data and we have the output generated transfer from time to depth, and this is what we are going to do in this course, using some of the software to do that. So real seismic recording in the field. This is before the processing. Before the processing, when we receive the seismic data, it has multiple noises. One of these noises is called ground rules. The ground rules, it has low frequencies and high amplitude. And also the true reflected seismic wave is hidden within the ground rule. So we need to first remove the ground rule so we have the true seismic wave. So removing the noise, this is the most important part in processing. We have time and trace number. This is the trace number, the distance between the geophones and the time. So we need to remove the ground rule. If you see, these are the true reflections, and you can see the interface of the ground rule, how is interfere the seismic real reflected seismic wave. And first we need to remove the low frequencies and the high amplitude that affecting on our data. Okay, so on here the same, the time with the amplitude, we need to cut this part that have low frequencies, and we keep the part that have high frequencies. So we remove all the ground rules and the reflections. There is also reflections that is very low reflections, but we need the reflections, the true reflections that give us the subsurface geological layers. These are for the surface reflections. We are not focusing on the surface reflections. We need the subsurface reflections. So we have to cut the data from here to have only the geological subsurface reflections, and also with removal of the ground rule. So what and where to observe seismic signals? Only the reflections are signals, the rest is noise. So all the reflections are signals and all the rest are noise. So we have air waves is considered as noise. We have a ground rule is considered as noise. We have multiple considered as noise. Also, in the case of land seismic, we have noise coming from the surrounding area. For example, if you have any subsurface noise, all this considered as noise. So we need to skip a part of noise and we set our offset. Only reflections is our true signals, and all the others considered as noise. So we need to cut all the others noises and we keep all the reflections. And this is what we are focusing in this course. We need to remove all the noise and we keep all the reflections. So this is all you need to know in this lecture. So thank you for watching and see you in the next video.